Cool. Hey folks, it's that time of year again, and we're deep in final projects. I am working on something that I'm actually pretty stoked about, and I thought was kind of cool enough to stream the rest of my process on. Now, I'm not fully done with it, and it still has a bunch of work to be done. A lot of that is going to be retracing our steps, but I don't know. I'm here for the ride and for the chill vibes. So I've got my tea because I saw they removed the arts and crafts section on Twitch, so I have to fit in with that just chatting group. So let's do it. Clever diversion, sound levels are good. Well, cool. All right. I have a bit prepared already. So I guess I should explain the project first. Let me sketch this out for y'all. I was talking with my friend who used to work at a hospital, and during the coronavirus pandemic, they had a bunch of new protocols for cleanliness. They've always been very careful around medical gloves. There's this whole process that you have to go through before you get some of these, nitrile gloves off the wall. You've got to wash your hands. You've got to sanitize your hands. You've got to, Stud the Avocado, dude, you sound awesome. That's great. I've got this fancy mic. My friend's lending it to me. I'm very thankful. But sanitary procedures around medical gloves. That's what we're working with today. I had this idea for an enclosure, thanks to my roommate. When he was working in the hospital, he had to wipe down and sanitize all of these surfaces, and you can't wipe this thing down. Like, what are you gonna do? Take all the gloves out, wipe them all down individually? It's just not gonna work out. So I wanted to make something that you can wipe down, that you can sterilize the surface of, in a way that's just a little better than just running a washcloth along it. I know that's not how you do it, but you get the idea. So when I'm working in CAD, I always like to work one piece at a time. Before we get to this CAD document right here, let's sketch it out. I always love a good sketch. We're looking at let's just draw the glove box for now. We've got good old isometric glove box. Just a rough sketch, nothing too fancy. Wow, that is completely out of proportion. Let's make it a little fancier than that. Yeah, there we go. It's around the right proportion, right about there. Let's cut the rest of this. So let's just get these out here. We've got our box of gloves. Got a bunch of gloves in here. These are gloves. You can tell that, right? So, glove box mounted on the wall. You walk up to it, you do the whole process, you grab your gloves, and then when you take them off, you do it all in reverse. So we're gonna need to put some sort of enclosure around this, and I want to make it a really easily openable enclosure. And because honestly, like, who wants a new piece of equipment that just complicates their entire process of what they usually do? We want the purpose of this thing to be very clear to this medical professional that we're imagining in our head. So I want you to be able to see through it. There's no obfuscating these gloves. I want you to be able to see where the gloves are. There's no question about what this thing does. I want them easily accessible and ideally without using your hands to open this enclosure. So that means some sort of maybe a foot pedal, maybe a button. Button seems a lot for this final project. You know, it's due on Tuesday, so I don't really want to, you know, get an Arduino out. But that's what we're working with. So I was thinking, how about some sort of transparency? Ooh, it's a rough drawing. Let's see if we can get this a little. This flap can have a nice there we go. You can have a nice fold up flap, and this will be on top of a whole case, and maybe we can have a little, you know, string attached here. So the string will go up here, and then it's going to have some sort of pull on the string, just so you're not using your hands. I'm using this pedal solution, by the way. It'll all make sense in a minute. So I'm going to route the string around to the side and then down to the floor. This will let people, you know, pull on the string if nothing else. I just really want to make it super clear on how to open this. So, you know, in an emergency, somebody needs gloves, they're not going to have to mess with my whole system if they don't want to. I want it to be very unobtrusive. So I'm going to have some rollers on this string, you know, route the string path up to a nice place. And the reason I've routed it off to the side here is I wanted to make sure that the glove box could be taken out of this enclosure. And you're starting to see what I've made up here on this side of the screen. We've got, let's do a quick side view. We've got the glove box side view, gloves sticking out. So we're looking at it like this. Sorry, like this. And I want a nice solid enclosure for this that holds the box in place. So let's have a nice, I'm thinking 3D printed, but you know me, that's all I ever think about. Want some little, you know, pieces holding the box in right here. But then we also want to leave a little space for the gloves. So let's have another little piece out to here. So now we need to close it all off, and that's where this this transparent flap comes in. So the transparent flap will come down here, and you know, I'm thinking a magnet right here and here. And then when we need it, we'll just pull that transparent flap up with the little string we got going on. A little string right here that goes here all the way to the floor. That's the thought anyway. Not sure if that's shown up super clear in the stream, but yeah, that's what I'm working on. So hopefully we can get this looking kind of good in actual CAD. Things I'm not super sure about yet. I'm not exactly sure the interface between 3D printed parts and this transparency. I got some ideas, but you know, I'm gonna need to try some prototypes first. And yeah, I think really this entire stream is just gonna be a bunch of me staring at the screen saying like, ah, shoot, how am I gonna do that? But that's just chill CAD vibes, and we're here for it. So let's get started. I'll show you what I've got so far. Right from the start, I've got this sketch right here, it's really just the, let me show you. First, made myself a dummy glove box. It's just the basic measurements of this box right here, translated, you know, length and width, extruded for thickness, and then a little slot just to show where, you know, this slot is located on the front, so I don't block it. Hey, Vofwin says hi. That's pretty exciting. I didn't expect anyone to actually tune in. Hopefully I won't disappoint. Well, as I was saying, we've got a dummy glove box. It should do the trick just to make sure I don't run into anything. Not actually planning on making it, because I already got one. It's parametric, so any glove box should fit just as long as I have those dimensions. I can just go back here, change it. Every single change will waterfall through the entire model. Pretty stoked about that. But now that I have that glove box done, I can just turn it off, work on the main enclosure. It's pretty exciting. Vofwin. It's a cool username. Says it looks cool. Thanks. I appreciate that. I'm working on it. Here, let me run through the rest of it, and maybe it'll look even cooler. So, have a few tolerances: 1 millimeter on the sides of every inch of this box. Hopefully, that should let it slide into this enclosure nicely. We're gonna find out. I'm sure, you know, I'll be printing this, you know, Monday night, just in time to be late for my project. You know, making the walls here. Finally, we get an actual extrusion out of this. And cut out the front. Oh, where's this front? Oh, wow. I need to rearrange these. Here we go. So, I had this great idea just before I started the stream. How long have you been Well, let me get to this great idea first. So, a big problem with what we're looking at with this glove box enclosure is we don't want to make it too difficult to swap these boxes out. So my dream is to have someone walk up to it and no fiddling around with the actual enclosure, drop it in the top, it's good to go. That would be my hope. No, you know, messing around with a string, no opening doors. So I want to leave this top channel, this surface right here, clear to the top. That would be my ideal. We'll see if we can actually do that. But I thought, how are they going to get it out if it's all the way buried in this? And we're looking at, you know, before I've cut this corner here, you can't get your fingers in there. If you want to like reach through the, let's just take this and drag it. If we want to reach through this, oh boy, what have I done? If we want to reach through, remove the box, it's going to be a nightmare. I don't want to do that. So I also need to have this string that I've got right here, the red string, to route around to the left of the box. Here I've got the string routing along here. So I wanted to leave at least one of these sides intact. There we go. Just cut out a corner. It looks good. And we can even round off the corners a little bit. I usually leave fillets, chamfers to the very end of the model. I'm probably going to remove this one just to use it as reference geometry, but I wanted to see how it looked. So that's where we're at. Now, Vo Woofin asked a question, how long have I been using Autodesk? Jeez, I mean, I think when I started really getting on the path of 3D printing, must have been, I don't know, maybe 3 years ago? I'm sure some of my more dedicated viewers can answer this better than I can. Yeah, so I think about that long, but I have been using, you know, CAD packages like SolidWorks, Onshape, Fusion 360 like this for longer than then, just not quite as seriously. You know, I took a class in it back in like, I want to say 2009, 2010, on, you know, just general SolidWorks usage. I got a B. I, you know, didn't really understand how exciting it could be at the time, but, you know, over the past, you know, 3 years, it's been something that I think about constantly. So, yeah, I can't pretend to know the ins and out of CAM, but CAD is my bread and butter right now. Vofen says, I have some experience with Autodesk Inventor, but have been big into using Multisim lately in digital electronics. I haven't heard of Multisim. So I've played around with Autodesk Inventor. I think that with Fusion 360, which is kind of the hobbyist version of Inventor, I feel like, but has kind of branched into its own product, just because of the interface. And frankly, I've seen a lot of professionals use Autodesk Fusion 360, even, you know, instead of Autodesk Inventor these days, which honestly surprised me, because I think the same team who works on Autodesk Inventor put in, frankly, well, left out some features that I think are frankly just, I'm still in disbelief that they don't have a Helix tool. I don't understand it. Like, why would they not include that? And no referencing of existing driven dimensions. It's just, it seems arcane, but easily the thing that keeps me coming back to Fusion 360, even on top of Onshape and SolidWorks, and nowadays FreeCAD, is the components management. The sheer ease and cleverness of how Fusion 360 handles components is just so nice. And the fact that I can project dimensions from one component to the other component and really keep things entirely parametric, it's good. Vofen asks, you ever breadboard? So the breadboards that I'm familiar with are the hold on. Breadboards. Here we go. Are you talking about this sort of breadboard? Because these are the only type of breadboards I'm familiar with. If not, then no. If yes, then yes. Not as much as I've used CAD, but... And hopefully I won't have to use too much breadboarding for this project, because it is due quite soon. Really running for, we'll see how long I make it, but really running for an all-nighter CAD session, you know? All right, so my next steps. My steps so far have been all interfaces between existing devices. That's how I like to organize CAD in my head, is I do one interface at a time. The first interface that I absolutely need to interface with is the box, the medical glove box. It needs to have parametric interfaces between that. Next interface is the wall. That one's easy. It's just a flat surface. I put some fastener holes. I made sure that you can get at these fastener holes with a screwdriver. Just, you know, it's nice. I didn't want anyone, you know, having too much trouble with this. Next, I need to create an interface for the transparent sheet that I'm using to make this transparent surface. So this is what I'm using. It's a transparency sheet, like the ones they use in, you know, in lectures. I mean, in older lectures. Nowadays they just use a projector, but an overhead projector, you could use this on top of your documents, write in whiteboard marker, annotate stuff. It was a nice time. And, you know, project it for the entire class to see. I had a couple of these on hand. They seemed perfect for the project. Ideally, I'd love to use something with a little more, you know, springiness to it, but hey, it's due Tuesday, so come on. And so I need to create an interface for this projector sheet. I'm thinking, you know, something with some standardized fasteners, you know, nothing too complicated. And then finally, I need to create an interface for the cable that we're going to have hanging over, you know, this piece right here. Boy, I should really draw this a little better. We've got the cable path right here, hangs down the side and attaches to the transparency. So this cable path might not be the most difficult part of the CAD, but it's definitely going to be one of the most difficult to prototype, because I'm going to need to do the whole thing in order to really see how that works. I put together a quick prototype of it earlier this morning. I might not want to attach it directly to the end. I might want to attach it somewhere in the middle, but every single thing that I attach, you know, in front of these gloves risks making it not obvious that this is a glove box enclosure, and risks people not really understanding what this device is for. I really want to embody this user design methodology. You know, shout out to Don Norman. That really makes it clear what this device is, and make sure that people have a very clear mental image of how it all works. Because if I can achieve that, then no one will ever have problems. Well, no one will ever have problems. Most people will never have problems using it, and most people won't even have problems fixing it or making it. So that's the docket today. We've got interface for box, done. Interface for wall, done. Interface for transparency, oh boy, we'll try. Interface for cable. That I think we can do. Yeah, let's see. Voafen says, I'm fascinating with taking situations and creating logic expressions and truth tables and using multisim to create the NAND and NOR gates AOI designs. Then breadboarding using a probe to test its accuracy. That's great. Yeah, that sounds like mechanical systems. I never took that course using like physical programming, but I always thought, you know, Boolean logic was just a blast. My undergraduate was in computer science, so I'm well familiar with some Boolean logic from coding and assembly. But I haven't really used a whole lot of physical NAND, NOR, XOR, XNAND, XNANDOR, you know, whatever you can think of. But today, so I am very impressed. That is a very fun thing to have as a hobby. Karna. Hold on, let me Google that. I saw this great XKCD recently, which was all of the Karna. Oh yeah, a Karna map. See, this is not something I'm familiar with. Simplifying Boolean algebra expressions. This would have been nice in logic class. Oh, that's fun. Yeah, seems pretty good. There's that XKCD logic gates. Yeah, here we go. I really enjoyed this one. I once again proves that I have no original jokes. But to CAD, because otherwise I'm going to get distracted and never actually do my project. Whew. And however much I would enjoy that. It's probably something that I should work on. All right, for now, gonna get rid of the fillets. They're pretty, but I really just need to be able to take a look at this front cutout and why is that projected? The corner cutout, here we go. So we've got our corner cutout and I'm just gonna leave it loose for now. We'll figure out exactly where we can put it after this, but for now, let's make sure that we have a solidified, a solid interface for this transparency. So one thing about the transparency is I don't think we should necessarily attach it to the top like this. I think that it would be a good idea, since we want to have this this box stick out a little bit, and we still want the transparency to have a hinge on the top. I thought maybe let's get another box here. Give me a box. Box. All right. So we've got our box. And we're going to enclose part of it. So we've got our cutout. Can't mess with any of this area. Let's just have an overhang here that sticks out. And here we go. Yeah. So we've got this stick out overhang. That'll give us somewhere to attach our transparency to. And then we can go down to the bottom of this thing. Wow, this drawing gets less and less clear, but hopefully you see what I'm saying. And it'll be even more clear in the CAD. If we can duplicate it. All right. Let's just start a quick sketch on this front face. Let's see. I've got my extrudes for the fasteners. Let's just run that back. I've got the main enclosure projection. Let's get rid of some of this. And yeah, that seems about right. All right, new sketch, front face. Let's get this, a little more of this enclosure finished. So we should start from the cutout at the very least and have this strut out. So this will be an extrusion right here. Let's see, how much do I actually want on this glove box to cover? Let's do 40 millimeters. That'll give it enough room for the gloves to stick out so you can easily grab them. Let's just do a good 40. So you can see this is where we'll attach the transparency. Maybe we'll have, just a set of fasteners lining the top here. We'll see what makes sense at the time. We'll have a bit of fun, filleting this later just to make it look good. It could be good. We'll have to figure out print orientation for this thing eventually, because I am going to print it using my Prusa. But hey, support material isn't nearly as bad as people say it is. And honestly, the overhangs here I could probably bridge anyway. Vofin asks, am I a college student? Yep. I am a graduate student, and this is my final project for design methods. Granted, I am coming in a little under the wire, but it's one I'm excited about, and have been looking forward to really, starting this whole medical glove enclosure project for a bit. I'd been thinking about it. Why not use it for a project, you know? And we'll get a V1 out of this eventually, and we can, figure out what changes we make based on the feedback I get from my cohort. Okay, so we probably want this to enclose the entire front of the box. So let's go ahead and revisit this sketch. We'll do a few bits of the enclosure here. And we'll just center this around the origin so that we can there's going to be a lot of backtracking in this, I can tell. I always have ideas in CAD that I tend to realize are the exact opposite of what I want a bit later down the line. So I know today is going to be no different. We'll see what we can do. Just make these equal. That should center them, and yeah, that's nice. This shouldn't be the midpoint though. Let's go ahead and make these coincident, not the midpoint. Oh, that's interesting. Let's go ahead and actually just put that reference geometry right here. That way, no matter what parametric forming we get, it's always about the same. Let's make this one, let's see. I want an M3 bolt to go through here, so let's make it a nice burly 6 millimeters, just for now. We can always change it later. And then, let's see. So we'll have that interface for it, and let's go ahead and make the sides an equal 6 millimeters. I'm not making them equal. Like sometimes I would look at this and I'd say, why not just make this line and this line equal? I always do constraints preferred over dimensions. And the reason I'm not doing that right now is I might want in the future to have this top piece of the enclosure. I might want to have it a bit thicker just because of all the interfacing it's going to have to be doing with this transparency sheet. So, Vofin says, I'm in the 11th grade and your stream seems like a gem. Yo, thank you. That's a huge compliment. I really appreciate it. Thanks for tuning in and for the follow I saw. Appreciate it, man. Yeah. All right. Let's go ahead and just terminate this at the bottom. I'm gonna need some sort of... So, once again, we look at our enclosure. The one I've drawn here, it terminates at the bottom. You can see that this, the actual piece ends at the bottom. We probably can cut a little space here. I'm not basing that on anything. I'm just I'm thinking it through, and I'm sure I'll change it later, but we'll call that good for now. Let's add a little reference piece of geometry. Let's see. So I want this whole thing to close in a way that that snaps it closed with magnets. I've got a few of these little bar magnets right here. They're 20 by 6 millimeters. Let's find out. We're looking at a good... The fun part about measuring magnets with calipers is you don't really need to squeeze them closed. You just snap one to one side and the other side just snaps in. And we're looking at a good, 6 millimeters wide, and pretty sure these are 20. Yep, 20 millimeters long. Looks like 2 millimeters thick. Yeah, cool. Okay, so at the very least, this bottom portion is going to need to fit one of these magnets. And I'm pretty sure, yes, like this, what'd I say, 6 millimeters? Yeah, so on either side of this magnet, we probably want a good 2.5 millimeters thick of wall, just so that we can have a nice solid enclosure for it. I'm not doing anything fancy like inserting the mid print. Well, I guess I could. I just, this is going to be a long print as it is. Imagining, waking up at 6 a.m. to insert these mid print when I could just glue them in. I think that's just probably my play for this one. It's only a prototype, and I'll do the full mid insert print sometime later. Vofin says, do you have any coding experience? Yeah, so my undergrad, I'm a computer scientist, and that's my undergrad profession. My bachelor's is in computer science, and whatever that brings. Really, my greatest proficiency in that realm is Linux administration, and I don't know, like SQL databases. So I know that's not SQL isn't a programming language like Python. So I guess if you wanted to know which programming language I'm actually somewhat experienced in, I'd say probably Python or C. Where do you go to college at? I don't know if I feel comfortable saying that on stream, so you'll just have to guess. I don't know. I'm pretty stoked on it. I ended up going to grad school at the same place I went to undergrad. I was thinking about going into industry right out of college, but some folks in a department reached out to me, and they're like, "Hey, we have the perfect place for you," and they did. My program has been extremely up my alley, and has allowed me to do the CAD that I do as a hobby, in my academic pursuit. Oh boy, these magnets have gotten all messed up. Let's see if I can get this back into a fashion where we can put them back in the box. One thing about magnets, can't put them back in the box. All right, that looks securable. We'll get back to these later. Okay, let's see. Hey, thanks Vofin for understanding. Now we get to what's probably going to be the majority of the stream, where I stare at my screen and go, the part we're working on right now is the interface between our enclosure and this transparency. I think I'm gonna do something in order to secure this thin sheet. I think I'm gonna pop a fastener through it. So something like, let's just go ahead and take this. Oop, not the whole thing. There we go. Let's make a few of these construction geometry too. Bam. Now they won't extrude. Oh, can't forget about the bottom. We don't want this extruding either. Okay. Oh, one more go. Get rid of this this middle profile. Cool. Okay, so we've got our space for the gloves to exist without being touched by this flap. We're going to have to figure out how to put magnets down at the bottom here eventually. But what I was thinking for the interface between the transparency and the let's get rid of that. I had this thought for the interface between the transparency and the enclosure, and transparency in a 3D printed part, and it's something like let's just do a quick sketch on how I do this. You know, something super thin. There's a side view. And we just punch a hole in this. This will make a lot more sense once I actually finish it. Let's make a quick sketch on this side. We've got holes for the fasteners and the heads. And we've got punch these things all the way through. And punch these a little shallow just to sink the heads in. It'll look good that way. Once again, this isn't a part that I'm actually, you know, completing on this. I'm just making it for demonstration. Then we have, you know, the holes for the fasteners on this side. Let's do a quick polygon just to show my intention. Cool. So this should give you the idea of kind of what I'm going for. Whoops. Different profile. Here we go. Bam. All right. So idea is you pop the transparency into this slot, and then you poke a hole through it and you get these, you can pop a fastener through that hole and that'll keep the transparency nice and fast into this thing. I don't know how well this is going to print, and I'm sure there are more elegant solutions than using, fasteners to attach this transparency through, but it was just a first thought. Why not get a prototype out there so I can actually figure out what problems I'm not thinking about? Vofin says, don't mean to distract you, but have you used Robotic or used Vex parts? No, I haven't heard of either of those. Let me look them up. Let's see. Looking at ROBOTC. Robot or Vex Robotics? Huh. Looking at 1, 2, 3. This looks like a rapid prototyping, coding robot system. That's fun. It looks like it has like a block-based coding system. I learned on those. When I was a kid, the best toy my parents bought for me, I thank them so much for this, was Lego Mindstorms, because the Lego Mindstorms had the ability to make projects that I actually wanted to do, and actually really drove me to really think about the answers. And that was very unique when I was a kid. But the way you programmed these robots from this controller is good old Windows 98 had a program of Lego Mindstorms that had those drag and drops, loops, variables, drive the motor 6 seconds in the clockwise direction. It was great. And honestly, I attribute that to me doing a computer science career. That was easily my my catalyst. But yeah, it looks very similar to that, and that's really cool. I'm glad that people are still making stuff like that. Let's see, I just got a Slack message. Cool. Man, it's great to see my cohort working on similar projects to mine. I've got a friend who's working on his project at the same time as I am, and he's doing motion interfaces using machine learning visuals. What is it called? Computer vision. Yeah, so he's using this library called MediaPipe, where you have this it uses only computer vision, no LiDAR, no infrared scanning, just a webcam image to completely do inverse kinematics on your hands, your face. It can do expression detection. It can do gesture detection. It's great and surprisingly accurate. He was running it on his like old laptop too. That's one of the best things about machine learning algorithms is you sacrifice, complete accuracy for so much speed. Oh, it's so exciting. And all you have to do is train a model. You have to, the model ends up very fast, very small, and you just end up with this very efficient, algorithm that you can use to estimate. And he's using it for a project where he's making this drawing machine with like hand motions. It's really cool. I'm excited to see, the final project actually show up. Oh yeah, MediaPipe. Yeah, MediaPipe is awesome. It's the future of AI technology. Oh, it's good. Yeah, and it's Python too. Like, how approachable. I love it. All right, so let's see if we can finish before him. He's prolific in the program, so we'll have to see. But here's what I'm thinking for the interface. Maybe we can make this not, we might even be able to thread some fasteners directly into the 3D printed part. It's a prototype. That's allowed. It's chill. Studley Avocado asked both when have you used any SparkFun stuff? Yeah, like I hope so, because SparkFun is really good, and we actually have some of the people who work at SparkFun closely integrated with our program. It's good. They seem like a really cool company. All right. Let's get rid of this little prototype at belt. Looking at the main extrusion. Let's get rid of that. Yeah. Get rid of these. Make sure we can really work with this. Okay, so one issue we're gonna have. Let's go back to this side view. Let's redraw. It's always worth it to redraw. So we're looking at new side view. And let me know if this isn't clear on the stream. Here's the gloves. We've got our side view. We've got our actual enclosure interface for the box. We'll show a little space between there, between the walls and the box. And then, so here's where we're at right now is, oh, I should have done these in different colors. Whatever, you get the idea. I'll do the next part in different colors. It is not really picking up. Here we go. So we've got our cutout right here, like right here, so it can't interfere with that. We've got this part. We're going to draw this line. We've got a part jutting out right about here. And that will be where we attach our transparency, which let's draw right now. So we're going to have a transparency go down and cover this. And then we'll have a similar piece up on top that, well, let's see. First, I know I'm missing something with the magnet enclosure on the bottom. So you'll notice that this entire surface is one plane, and I need the transparency to touch that plane. So if I have something on both sides of the transparency, I'm gonna have to leave space for it. So in order to have, this piece down here that weighs down and holds the magnets, let's draw a couple magnets in here just so we can visualize it. Here's a magnet. What a beautiful magnet. And then we've got a magnet on this side. Bam. These are attracting each other, as all magnets sometimes do. All right, so in order to interface with whatever we've got going on right here, and to touch whatever wall we have right here. Whoops, let's draw this in a different color just so it's super clear. Well, regardless, if our wall is on the same plane, it's going to be right here. This gap we cannot have. That ruins our entire premise. We can't have a gap between this clear front wall and the side and this side right here, because then we don't have a real like enclosure. We just have kind of a little cover. So what we're gonna do, I don't think I explained that very well, but still, it'll probably make itself clear as I keep going with this. We're going to have the wall extend. The bottom wall will be a little recessed. It's that distance right there. Recessed. So we've got this bottom wall recessed. We don't have it on the CAD model right now, but we're gonna make it. I know I'm making a lot of mistakes right now in my design. Like, this certainly isn't the final design. We're going to see a lot of change when it comes to this, but as long as I get a V1 down and printed and in my hands, then I can start this whole process over again, make a much better model the second time around. My strategy, I have stopped making models that I obsess over every single portion of it the first time, because I've learned, for me at least, by far the best way to go about this is to just get a prototype in my hands, and then I'll start to realize the exact way that I should have done it the whole time. And my V2 is always just, much, much easier to edit, much faster to make, and just better. So we're doing that. That's our goal today. All right. So we are going to need, I'm thinking about how we're attaching the piece to the top of this, because I'm actually second guessing myself. But you know what? We'll do it later. I was just saying that I wanted a V1 on the books, so that's what we're gonna do. All right, let's recess the front just so that we can get those magnets in. We'll just make a quick extra set of pieces here so we can separate these two, and we'll make this a little thicker. We'll also estimate how big the magnets are going to be. Let's see, I might have already put the magnet parameters in here. Nope. Okay, so these magnets are, I said, 20 millimeters long. Let's add a little bit on top of that. Let's do 20 millimeters plus 0.2. Hopefully that's enough to make it easy to, press fit in there. Maybe a little super glue. We'll figure it out. We'll do 20, and they were 6 millimeters wide, so let's do 6 plus 0.2. And then let's make both of these the same size. You are equal. You are equal. And you are collinear. You're flat. You're just construction geometry. Let's also center them. Maybe we'll have them on the edges. Let's just use a center line here and make it vertical. That means that they'll, stay in this right place. And then finally, let's make them equidistant from the sides. We'll just draw a couple extra construction lines and make those construction lines equal. That way, no matter where these lines are, they'll always stay right in the middle. Let's go ahead and make the distance between the magnets and the side a good beefy 3 millimeters. That seems good. It seems, kind of small. A 3mm wall. Oh man. So I printed this wall gauge. Whenever I show this print to somebody, they're always like, yo, I have a ruler. I know how long a millimeter is. I'm like, no, it's not quite it, because you don't know what a millimeter feels like. And that's what this print does. It's this almost Swiss Army knife style piece that has 1 through 5mm thicknesses. And you get to feel, if I print this wall in 1mm, what's that going to feel like? How robust is that actually going to be? And I've used it ever since, because, just having a 3mm wall and being able to be like, yeah, that's still a little thin. I think in this case, 3mm, it's a pretty good size to have this distance between the wall. Vofin asks, what type of 3D printer do you use? I'm a diehard Prusa fan. I think that Prusa is the company that's actually doing it right. They update their stuff with the community in mind. Their XL, the Prusa XL looks so good. Man, I'm going to have to do a stream on that at some point, just reacting to this fantastic, it has modularity in mind. It has paying attention to its active environment in mind, like no other 3D printer I've seen. And the tool changers, are you kidding me? Oh my God. I've got my pre-order in. I'm picking that thing up as soon as it's available. I've been waiting for that for 3 years now. Regardless, right now I have a Prusa Mark III S Plus. Bad naming scheme, but amazing printer. Yeah, no, I really enjoy it. I've modified it quite a bit. Hey, maybe I'll show it on stream here once I'm actually getting to the printing site. Yeah, Sell the Avocado, biggest hype for the XL. Oh my gosh, it's gonna be so good. All right, we're taking a quick break. We're watching the trailer for the XL. It's just too good. Let's get. Here we go. Let's pause my zero royalty hip hop lo-fi mix, and let's do this right. All right, I should probably move my webcam too, so it's not covering the subtitles. I'm up here now. This is a printer I have been waiting for 3 years. They started leaking it. The leaks were exciting, and one of the comments to this video, I think, said it the best. The fact that the absolute size of this print area is by far the least exciting part of this printer really hammers home how important these features are. So, first of all, amazing B-roll. I set these images as my desktop. RGB, let's go. And it just looks so good. All right, so first of all, it's got a bit of a different design than the printer that I have right now. I have a Core XZ printer, meaning that as it prints, the extruder, this part right here, moves back and forth on mine, the X direction, and as the print goes, it travels up. So we have a Core XZ printer. This is a Core XY printer. So as the print goes, the bed moves downwards, and the extruder is the one moving in the X and Y direction. So it has this set of directions, and it looks great. There's the bed going down. Oh my gosh, there's so much stuff. So they decided to go with Core XY because with this sort of build volume, you really want the overhead footprint for a Core XZ, like the Mark III's. This is what I have. really starts to get in the way. And they concluded, and I think rightfully so, that that a Core XY design is the right choice for XZ printers. I know that Studley Avocado has worked with a couple Core XY large scale printers, and I mean, we'll let Studley Avocado say in the comments what his experience was with that, but I think that it was bad. So good on him. Prussia got it right. Beautiful prints. All right. This load sensor is probably my favorite announcement for this printer, because here they're using it for bed leveling. A lot of printers before a few years ago, you needed to manually turn screws to level the bed. You needed to calibrate this thing every print you had. Probably not every print. Studley Avocado is probably going to correct me here again. But for me, I'd want it every print. And what this does, clever diversion, load sensor hype. Oh my gosh, yes. So this, my printer uses a little metal detector, and it tries to get an image of where the bed is, the print bed is in space. And then it will kind of determine where the nozzle is compared to that, and you'd need to turn a little dial to say like, whoa, the nozzle isn't that close, or hey, you're printing way too high, the nozzle is down here. This, you don't need to do that anymore. And that is one of the biggest flexes in the 3D printing world that I've seen, is the ability to say, we have a perfect first layer every single time. I have never heard an FDM printer be able to say that before. And if they're promising that, then I am there for it. So this actually probes the bed using the nozzle itself. So the printer not only knows exactly where the bed is in comparison to the nozzle, instead of having to do this math of like, well, the sensor, the metal sensor said that the bed was here, and we know the offset between the metal sensor and the nozzle is about this much, so let's put the nozzle here and hope it's right. This one actually can tell, and it actually taps the nozzle against the bed in order to level the bed. And I just think that's incredible. On top of that, the load cell sensor is sensitive enough to actually sense the resistance that the filament is pushing back up against the nozzle while it's printing. So if the print surface isn't pushing back quite as much as you expect it to, that means that you're too far away from the print surface, and the printer can correct for that. That's so good. So it's actually listening to its environment and it's adapting to it. And it's just incredible. By far the best bed leveling system. Hopefully, if it works as well as it shows here, that has ever been made. This huge flex. So that perfect first layer is one of FDM printing's largest problems currently, is because getting stuff to stick to the bed, getting stuff not to jam the nozzle because you have the nozzle too close to the bed. It's been a consistent problem for, the past of best bed leveling system since your mom. What? Thanks, chat. It is just another gigantic flex of the promises of this printer. It's going to be good. Next, you have this modular bed design, and this is another problem that's being solved with large-scale printers. Is I mean, from the large scale printers that I have seen in the past, you needed an entire other power outlet to plug in the bed, because it's a heated bed and it needs just this massive amount of power. And it was really difficult to get that thing flat. The modular bed design. Oh, and the other real problem with large heat beds is you're only detecting the temperature in the center. So if your edges are hotter or cooler or, any different temperature, you don't know. And if you have a part that's, close to the edge, it's probably not getting heated as much as the rest of it. So it's going to warp. Every single piece of this modular bed has an individual thermistor, so it can tell exactly what temperature is and it can compensate for it. That's great. It's another example of how this printer reacts to its environment in just this very exciting way. Man, and it looks so good. And you don't have to waste all of your energy heating the entire print bed. Here's an image of how these large ones warp. The magnetic print sheets, we've had that for a while. I wouldn't buy a printer without one, but always good to see that they moved it over. This extruder not only looks that good, like, come on, that looks amazing. But the large drive gear gives it more surface area where it's actually touching the filament. And that's really important because one of the biggest problems for me with current 3D printers is stripping the filament. So they'll show a comparison here. Okay, so I use these drive gears in my current printer. They do well enough, and they try to add more surface area by having two of them that push the filament through. But the problem that you run into is that if the filament meets too much resistance, these eat into the plastic and they will carve out these slots that then prevent itself from actually moving the filament. This larger one hopefully does not have that much of a problem. Also, hey, for anyone who's going back and looking at this video, this filament path is not the actual filament path. This was the only thing I was really worried about in the original announcement video, because there's just so much empty space here, so much space for filament, bunching up or missing, the mark. Given that I just rebuilt the extruder for my Mark III's, I found it very hard to believe that this was the finalized filament path. And I was right. They went over this exact issue in the live stream, and they have confirmed that the filament path is really good. And this is not, this is stripped away just to show you, the effect of how this filament path functions, not the actual filament path itself. Plus, they don't want to release all the details so that someone, releases a crappy version of it before then, and people start saying, oh, it's a bad printer, when the printer isn't even out yet, based on, these fake printers that people, end up in their hands. It's smart, and since they're open source, it is kind of a danger for them. But the entire printer will be open source once they release it, and they're going to release it when it's actually ready to be released. So hope it's soon, but regardless, pretty stoked about it. But that's not even the best part. Remember that load sensor? It's so good that it can detect when the nozzle is no longer actually extruding filament. Yet another incredible flex for them to say, hey, the problem that you keep having most commonly with your printer, jamming, bed leveling, you don't have to worry about it anymore, because this printer can detect when it's having problems with both of those. Once again, we get back to that incredible sense of paying attention to its own environment. That's why this printer is so incredible. Yeah, it can detect when it jams, and it can automatically pause the print for you to either clear the jam, or even better, since it's such a sensitive load cell, it potentially, with some machine learning involved, it could tell when it was about to jam and even prevent the jam altogether. That's incredible. And I can't wait for it. This right here, that takes me an hour on my printer. And they just did it instantaneously. Man. This is really smart. I'm really honestly genuinely surprised that I haven't seen this on another printer before. So the way a printer works is that it has one small zone where it wants to get really hot to melt that plastic. And a lot of the rest of it up here, they're like, please don't get hot. So they have something called a heat break, which tries to limit the amount of heat that creeps up this system. But if you have a problem called heat creep, you are getting the insane heat from this melting block creep up to the motor, creep up to, the plastic that's supposed to be solid. And it causes jams, it causes all sorts of problems. They just added an additional, basically a thermometer inside the part where you would get heat creep. So if you get heat creep, it stops. Why was this so hard? Prusa just does it right. Once again, another example of the printer listening to its environment and actively responding to it. It's good. Vofen says you should work for Prusa and make the next 3D printer. It's funny you say that, because I have been trying to figure out an email to send to them over the past several months, and I'm just nervous. Like, I hold them in such high regard, and they're one of the few companies I really think is actually doing it right. They're pushing the industry forward. They're doing it for the right reasons. They're open source, and the way they reacted to the pandemic, how they switched over their entire line just to make face masks and hand sanitizer when their local network had a shortage of them. I really think they are probably the coolest company that I know of, and I do want to work for them. I'm going to try and contact somebody for an internship. I can hope, but yeah, cross your fingers for me, because I would love that. But that's not all. This printer is so good. So the next extruder in general is just really smart. I've been asking for a breakout board like this on my printers ever since I had to replace the thermistor on my Mark 3S. I had to take apart the entire printer just to do wires. It shouldn't be like that. You should be able to have a modular system for your cable management. It's just a nice thing to do. So this is great. Same thing with the electronics, swappable boards. It's great. Some additions from the Prusa Mini here, the better electronics, the color screen. They're making their own version of Octoprint. Okay, linear rails. I don't know if these were necessary, but damn, are they nice. I believe them when they, like, for a large printer like this, you really need that rigidity, and linear rails are a very expensive way to get that rigidity, and I think probably the right way. Prusa has a history of really being consumer conscious in where they source their materials from. They try to make, they try to skirt that line between very price effective and very high quality design. And if they say they need linear rails, I believe them. However, I'm betting that linear rails are the majority of the price of this printer. They are difficult to manufacture and very expensive to buy. So, hey, I'm going to be excited to own a printer that uses linear rails. Um, I just I'm excited because I think that a lot of these features that you see me getting really excited for are going to make their way down to printers, other Prusa printers, like the Mark 3S and the Prusa Mini. Prusa Mini, by the way, $300. Like, that's incredible. They might have changed the price a little now that they have like a kit and, since they upgraded a few of the components, but wow, that's affordable. It's a good printer from a reputable company. Anyway, I'm not done shelling for Prusa because I love them so much, but what I'm getting at here is I think that a lot of the features that I'm excited about in this printer are going to be integrated into the next version of my printer or the next version of the Mini. And you won't need linear rails for a smaller printer like that. So we're going to see these fantastic features at a much lower price, maybe a couple of years down the line. I'm really, really stoked for it. Because I want to see a Mark 3S, a Core XZ printer with the next extruder and with the modular heat bed. It's going to be so good. And it's the logical thing to happen. Side-mounted spool holders. I thought a lot about this. A lot of my work in the past with CAD and contributions to the 3D printing community as a whole has been dry box related. Easily my most downloaded project on Thingiverse and Prusa printers has been my magnetic PTFE coupler mod. I think I'm sitting at somewhere near 4,000 downloads on both of those platforms. I put that on my resume. Ooh. I always like to have my filament stored in a dry box. And that's the one thing that I'm kind of nervous about with this printer is I'm going to need to completely redesign a new dry box in order to safely store the filaments on the side of this printer. I thought about it. Can't really put them on the top because the Core XY design needs that tubing exit on the top to be very, very free. You can't really put a... Yeah, Voafin says this is $2,000. I could never. You say that, but you look at a Lulzbot printer, which is not even half as good. And like... given the capabilities of this printer, I mean, a Lulzbot these days, let's just take a look at Lulzbot. Let's put Lulzbot on blast real quick. Lulzbot. We're just gonna go here. Let's take a look. What is a good printer from them? Let's say a comparable 3D printer. We're looking at the Workhorse. This is $1,000 more. For, let's see, Prusa XL has 260 build volume. And this has... Oh, wow. Hold on. 280. Okay. So, 20 more, so about this much more print area. And it's that in Lulzbot has had a really weird extruder. It doesn't have the amazing bed leveling. It has this weird bed leveling system where they tap the nozzle against these plates, but you have to clean the nozzle first, and it like jams it into this weird brush. I am very disappointed in Taz, especially with their latest 3D printer, which is the Sidekick, which was supposed to be their consumer grade, I'm pretty sure, and has some very weird decisions and is clearly just made out of parts that were kind of cannibalized from the parts that they couldn't sell otherwise. This is my the first YouTube video of the loyalty-free music. So that's what we're listening to today. Anyway, when I say that this printer, the things that it does are surprisingly cheap, I really do mean it. Like, I think Ender and Prusa are the two printers worth buying. Like Creality, Prusa. These days, those are the two best hobbyist printers. And this one, that the linear rails are contributing a lot to the price. So we're going to see these features trickle down into stuff that just uses, precision rods. And that's going to be amazing once that happens, because we're going to see the same thing for much less price. And I'm so excited. But that's not even the coolest part of this printer. The entire frame. So I should go with the video. I'm getting ahead of myself. Gamer RGB, let's go. That's just fun. The cool thing about RGB is if you have these in print farms, you can really tell at a glance the status of your printers. Like if you've got a wall of printers, you don't want to look at every single one saying like, oh, I think I spotted one that has a problem, or I think I spotted one that's done and ready to be, picked up the print. If it's green, it's done, and there's no like, it's just, it gets a lot easier when you have good indicators like that. So I'm excited. Also, including lights in your printer setup is always just very nice to the printer, because, these things, they're hard to see, and it's a very fine, tuned instrument that you kind of have to like deal with. So when you're holding your flashlight trying to deal with the filament jam, it's never fun. So I'm glad they included lights. Thank you. So this is just good stuff that Prusa always does. I've contacted their support before, and the people who actually run that support line really know their stuff. Like they knew their, like you've gotten the impression at this point that I know something about 3D printing. I've been 3D printing for a few years. I know CAD. I've contributed to the community. They know their stuff, and I can say that very confidently. However, I wanted to pause on this thing too, because it has a fucking draft shield. Heck yes. And in the very beginning, you can see the draft shield tucked away. It's this part right here. It's not a full enclosure. They have two options. They're going to have a draft shield and an enclosure. I'm probably just going to go with the draft shield. And the draft shield is for printing these very finicky materials that love to just warp and pop off the heat bed, the hot bed. Oh my gosh, like this is fantastic. Just what I was doing before this was I was printing a skirt up the entire object. And that worked okay, but I've always kind of wanted an enclosure, but I didn't want an enclosure because my main printing filament, PLA, actually prints worse with an enclosure. So having an enclosure, or at least a draft shield, that I can turn on and off easily, this is game changing. Like this is absolutely fantastic. I know now for people who want to come at me for that statement, I know you can just leave the door open on an enclosure, but honestly, like I want to have a good looking 3D printer. I'm not going to be just leaving cabinet doors open in my kitchen. I don't know. It always seems sloppy to me. This doesn't seem sloppy to me. This seems just so smart. So, and they also say, even more stuff like this, can you believe my hype? Like I woke up, I see a tweet. I'm like, the XL. And I jump out of bed, I go to YouTube, and I get the absolute hype of this video because I've been waiting for this thing for years. And just like, imagine now we're going to announce more exciting things right before launch. I'm like, yes! Man, you can tell how excited I am about this. Anyway, it's great. And then you get to the coolest part of the video. The absolute flex from Prusa. Yes! That's incredible! I've been wanting something like this for such a long time. I never thought I'd be able to afford it. Interchangeable tool heads is so... It is a paradigm shift for me. In the past, I've had to choose... let's see, I'm printing a model. What size nozzle do I want? 0.4 is what everyone is designed for. 0.6 will be faster, but with less detail. I've got, these little small nozzles that are good for, little mini figs or, whatever, but it takes an hour to change. No, you can have 5 sized nozzles and change between them mid-print, and you can put a different material in all of these nozzles. And that, so my current printer, I have something called the MMU, the multi-material unit, that lets you print in multiple different colors, pretty much, because it uses the same nozzle. What it'll do is, here's my print nozzle. It will pull out the filament, switch over to a different filament, and just slide it in. There's some problems with this. It's really cool. And I printed my my business cards with this, and they've been a hit at grad school. And it's really fun, but it is finicky. Every time you swap out one of these filaments, you still have to clear out the filament that's still left in the nozzle. So you go over here and you just kind of extrude some filament into a waste block. And it seems a little sloppy. It's cheaper than you think. It doesn't actually get rid of much filament like I thought it did. I think my most expensive white block I've ever had was 20 cents of material. It's nothing. But this doesn't need a white block. You can print materials that have drastically different melting points. I could print PLA, my most common filament with one tool head, and I could print flexible filament like TPU with another. I could print parts that are part, solid and part flexible in the same print. That's so cool. That's not even mentioning all the possibilities that this has on additional tools. Oh yeah, Carbon Speed Dating says show off my business. Hold on, I've got one. I can't show off one side of it because it has my email on it, but here's a good example. Here's my business card. And it's this solid piece of PLA that just has a multicolor print on it. And I don't know if you can quite see, but it has this great texture. I designed it so that I would pick up the texture from my build plate, and I have the texture on both sides. Let's see if I can cover up most of it. The other side has information like a QR code and my email on it. And it's just this nice solid piece of plastic that I can just be like, hold on. You have to get the sound. Hire me. Man, yeah. So the MMU is great, but imagine being able to print the text of this using a small nozzle, then mid-print, putting down the small nozzle, picking up a large nozzle, printing the rest of it ultra fast. That's amazing. And I've never seen a printer that can do this before. Having 5 independent print heads is so exciting. Let's see, how much do these cost each? So my business cards cost me maybe, I don't know, maybe it's less than $1 per, but I'm not really someone who's giving out a lot of business cards. And I like the reaction every time I give one of these things out. But I recently upped the cost a little bit for a really fun effect. I started getting these Nfc stickers. Hold on, I'm gonna go down. Oh, where to put them? Here we go. All right, so NFC stickers are the same sort of circuit you have in like Nintendo Amiibos. They're basically a little chip that holds a little bit of data that doesn't need a battery to be read. All right, so just got a bunch of these stickers. I wonder if I can get a flashlight, or here, I'll just use my phone light to show you the circuitry inside. Let's see if this shows up. Oh, that's going to be hard to get on camera. Let's turn down the brightness a little. Oh, where things are getting out of hand. Okay. Okay, low brightness. We're going to start to see. Yeah, there we go. We've got a little bit of the circuitry in there. And it's basically just a large antenna that doubles as the power receiver from the reader. And oh yeah, well, I put one of these stickers in every single one of my business cards, so you can just tap your phone against it. Here, I wonder if I can show this off. Please work. Bam. And it opens up my website on your phone. It's not even like a QR code. I don't know. I just thought that was cool, and I wanted to put one in. And each one of these stickers costs like 50 cents. So that does up the cost of each one of my business cards. But I thought it was cool. Like, yeah, dude. Wow, this... I don't know how this was supposed to be. We've got up, up, down, 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 up, down, down, up. Like, this is very difficult to fold back up. We're gonna do this. We're just gonna do this. Oh wow, it's fixed. Regardless, like I've had a lot of fun with these, and it was a good time making them. But these tool changers are so exciting for me because I've always wanted to change my 3D printer into other tools. Now, a 3D printer is very similar to a lot of other tools because all it is a thing on an XYZ positioning system. Vofin says, wow, the website phone tap idea is awesome. I might have to use that. You should. It was surprisingly easy. I bought the stickers on Amazon, and there are, just phone apps for writing and reading NFC cards. And most modern phones have NFC reading passively. Hey, I'll show you something else cool. Let's just go in here, NFC reader. And I'll show you something that I have. All right. Got ready to read. Got my hands. Please work. Yeah. So I have an NFC chip implanted in my hand that I had a friend do. And I just did it because I had a lot of projects in mind for it, and I've been wanting to do it for a very long time. I don't know. I just think it's cool. It's kind of like a piercing, but, an even weirder conversation starter. But currently I use it to like authenticate with biometrics. I think my favorite part about my chip implant is, a cyborg piercing. That's what it is. I have a bit of an interest in cryptography. I never really went into it in my undergrad, but cryptography or authentication of a user has one of three things. It's something that like a password. A password. Something that you have, like a key or a card. Or something that you are, like a fingerprint or any sort of biometrics. The thing that I like about this biochip is that it turns something that I have into something that I am. And I think that's a really exciting concept in cybersecurity, which is, one of the things that drove me to pursue one of these for such a long time. And hey, I finally got it. That's so exciting. Back to the tool changing. It really is the concept of a platform is one of the pieces that I am actively studying in graduate school. An open modular platform, so that you're not building a product. You're building a product that lets you're building a system that then you use to build a product. And this allows a lot of really cool stuff for a community around this product. So let's say instead of designing a wall mount for your vacuum, like that one, you design a wall mount for pegboard and then a pegboard attachment for the vacuum. Now, instead of making, something that can be used once for one product, you have something that other people can start to benefit from. It's not the best example, but you see where I'm excited about this and why I want to study it extensively, and hopefully at some point contribute to it. Modular systems are probably my most prolific passion. Whenever someone says the word modular, everyone in my cohort, it goes like, "What do you think, Will? What do you think about that?" I'm like, I do like it. So to see so many modular pieces of this printer really hammers home how, alien seeking cow, modular, modular. That's how I react. To see so many modular pieces inside this printer is just so exciting for me. And from the electronics to the extruders to the heat bed to even the frame being made out of these aluminum extrusions so that you can mount stuff to the exterior very easily, I'm seeing them do all of it right. And that makes me so excited. So thank you for bearing with me while I take a break from my project that's due very soon to rant about how excited I am about the Prusa XL. It really is a huge jump in the 3D printing industry, and the rest of these companies have a lot of catching up to do. Prusa does it right every time. It's good. Yeah, Alien Seeking Cow. We're going to see a lot of good stuff in the entire industry come from this one printer. I get the feeling that a lot of people are going to be copying, all of these concepts. Vofun says back to business, and they are right. I have to minimize this video that I have watched. I wish it would show the watch count for just me, because I'm pretty sure I've watched this video so many times. Anyway, let's move my video back down to a little less obtrusive space. Let's get back to positioning these magnets in this enclosure. All right, so for those who I've only ever used Lulzbot until now. Can't wait to get my hands on this. Yeah, Lulzbots are good printers, but they haven't updated their design in, I'd say, 3 or 4 years, and the industry has advanced so much since then, both in design and reliability, frankly. They have a lot of expensive components that are now really not very necessary now that better ways of doing the same thing exist. One error. Oh yeah, it's because I'm in a sketch. Okay, we're good. Let me drink my mass Gatorade. I'm out of tea. Okay. Quick poll. Does anyone in the chat... thanks for the follow, Alien Seeking Cow. Thank you. Honestly, that's very flattering. Okay. Does anyone in the chat need a refresher on what we're up to here? Because I've made a few drawings and they're bad. Just let me know. I'm going to talk through Oh God, don't quote me on saying lulzbots are good printers. That is not. I. You got me. Yeah, Studley Avocado used to work at lulzbot. They're not great compared to Prusa. Yeah, I really think Prusa is the ones doing it right. But boy, I'm procrastinating a lot from my project that's due very soon. Okay, so an overview would be handy. Okay, so I'll start from the top. I am currently working on my graduate school final project for my design methods course. It's just a final project. I was supposed to be working on it for a bit. We're working on it a lot tonight. I'm going to be here for a bit. General concept. Hospitals have these glove boxes hanging in hospitals. Let me start again. During the 2020 coronavirus pandemic, a lot of new systems for hospitals were introduced. A lot of them had to do with sterilizing surfaces that were open to the air, since it is a water vapor. It does have some transmissibility through water vapor, from what I understand. I'm no expert in this. And so sanitizing surfaces is arguably one of the best way to sanitize surfaces. Tautology. It is so hard to sanitize this. What are you supposed to do? Take the gloves out, sanitize each one? Like, they're sticking out of here, and that's just kind of how they exist. So I wanted to make a glove box that was physically enclosed, like out of the air. You only open it when you need to access the gloves inside. And this system would be a lot easier to wipe down than, this surface that's just weird. So that's my project. I wanted to make something that was a little easier to sanitize. The way that I'm going about this, as I show in this kind of weird sketches, is we've got the glove box from the front here, and we're looking at a little enclosure. This is the box we have right here. The glove box is this piece inside it. And the concept is we close off the glove box, but we still want to see that there are gloves inside. We have to make sure, or else people are going to be like, where are the gloves? I can't find them. That would be a shame. We need to make them easily accessible, so we can't be like pushing buttons or doing anything too arcane in order to access these. So what I'm thinking is I'm using one of these binder transparencies. It's just a clear surface, and we're going to put the glove box behind it in its enclosure. And the way people are going to access it is we're going to have a mechanism to lift up this transparency. And then when it drops back down, it'll seal it up. And that way, if somebody, coughs at it, it's going to hit the barrier instead of the gloves inside. So that's the ideal. When I'm designing CAD, I design in, here's how I think about it. I design one interface at a time. So far, we've got the interface between the enclosure and the box complete. We've got the box sliding in here. Goes zoop. Oops. It goes zoop right in from the top. And we've got an enclosed box. Next, I designed the interface between the enclosure and the wall. We've got these little fastener holes on the back. You really just, you've seen these before on most things you mount on the wall. You put a screw in the wall, you pop it in, slide it down. Done. Easy. Next comes the interface between the enclosure and the transparent sheet. That one's more difficult. And I had some ideas earlier in the stream. I'm going to try and implement some now. This is where the stream gets a little tedious, because I'm going to spend a lot of time going like, maybe I should, that's going to be a large portion of this. But finally, after that, before I'm done, I need to figure out the mechanism that takes this and pulls it back. And I think right now that's going to be a cable of some sort. I'm planning on the cable in this image is represented by this squiggly blue line. It attaches to the end of the transparency and gets pulled through this channel and hits these two bearings. I really want bearings on there because I don't want the cable to get jammed up. That would be a huge shame if you opened it and it just stuck open. It would ruin the whole purpose. We really need it to close again when all of this pressure is released. So, Vofin says, I wish I could stay, but I'm too tired. Have fun with your all-night CAD grind. Thanks, dude. Have a good night. Hope to see you live again someday. Thanks. Yeah. Hopefully it won't be a good 2 years between times this time. I'll try and make that happen. Yeah. Have a great night, and thanks for dropping in. Okay. For the hinge between the transparency and the enclosure, we need to figure out some sort of way that the enclosure holds on to the transparency. I was thinking that... Okay, so one thing that I did address before going on a rant about Prusa is if we're having this whole thing closed by magnets, which I'm really hoping to do, we need this bottom section to have a little offset so that the place holding the magnets can really be flush with the rest of the enclosure. So we're going to separate that out into a different thought. I have it all here right now. I think what I'm going to do is I'm just going to go ahead and delete that, and we'll save that for, let's see, we'll save that for a different sketch. For now, let's finish off the sidewalls. And let's see, we've got, we really want to make this transparent. Okay, cool. We've got our sidewalls. We've got the transparency that's going to be hanging down over this piece. How are we going to have this system work? I think my best bet right now, I'm going to try and let's see if I can do a quick mock-up here. We'll just have, quick demonstration CAD. So this will be, pop this out a little. Bah. Okay. So my thought is we have the transparency go into this this piece right here, slot in the top, and then we have fasteners. Let's create a sketch on this side. Got a couple circles. Well, a few circles, I suppose. These fasteners will go all the way through. And let's also do we'll recess the fastener heads as well, just to make things look good. And then on the other side, we'll just have a spot for the bolt. Maybe we can do a drop-in bolt if we're feeling fancy. Depends on how anxious I am about how soon my project is due, Let's just have these bolts recessed in a little. Bam. So with this system, I could potentially drop the transparency in the top and have it held in by two holes that I poke in it. And the holes will hold the transparency in place. And all you have to do to remove the transparency is just unwind these bolts. It comes right out. So there's this solution, but the other one I was really considering, let's do one right beside it. Let's have the same thing. It doesn't use it doesn't use fasteners, which is very appealing to me. Let's just make it quick. Here we go. These are, I'm not using these in the final piece, just using them as proof of concept. So in this one, what you do is you put a nice fold onto the end of the transparency. You fold it, and then you take this and you slide it in. This has potential because, like, hey, it doesn't use fasteners. How cool is that? And it might grip pretty well, but I've never really tried this before, and it seems kind of difficult, especially to fold this thing. This thing is kind of finicky. I don't want to fold it. So I think I'm going to use this first option. I really wasn't sure until I did both of these, but I think this one right here is the best bet. Fasteners, pretty dependable, and don't really have too much, too much to think about. I'm not trying too much stuff in this first prototype, so should be good. Let's go ahead and find where I actually started these and delete all of this. Now that I've thought it through, let's start by taking this top overhang, and we'll start implementing that. We'll need it to be thick enough to actually accept. I'm planning on using M3 screws. That's let's see if we can get a better image of that. M3 screws, they're my usual go-to. They work out pretty well, and they're relatively common, at least if you're not in the US. So we need to make sure that this part is thick enough to actually accept the M3 screws, because if it's too thin, we're going to be screwing them in. This is going to shatter the material, and we don't want that. So fortunately, I can just start to let's see. We'll probably want a few of these fasteners, and we want them to be centered. So we've just made a circle. We're going to make it 3 millimeters. Let's actually make it, let's make it kind of tight, so that the thread can cut into it a little bit with this fastener. We'll make it 2.8. That seems about right. Well, it's a prototype. We'll figure it out. I can drill it out if not. We really want it to be centered between these two walls. So I'm going to draw 2 lines, top and bottom. They're just going to be constructions. They don't actually affect anything. And we're just going to set them equal. And that way, no matter where I drag this thing, it's always going to be... Ooh, wow. Okay, that's wrong. Hold on. Let's just make that parallel to the top really quickly. Okay. Oh, that was close. Wow, what else isn't parallel? Let's start dragging stuff around. Yeah, look at that. Parallel. Let's fix these up. Okay, looks good now. Anyway, so now even if we make this like 9 millimeters, that circle is still going to stay centered between the 2 lines. That's great. That's good to see. I mean, we could go for a pretty cool aesthetic here. And we could do like a bunch of these across the top. I always love that over, lots and lots of fasteners. It's just an aesthetic I enjoy. I don't think we need it. I think we could do 2, maybe 3 fasteners across the top and just have a bar that sandwiches it in place. I think that's the best bet for us. So let's do that. We've got our prototype here. Yeah, that's the play. So let's just go ahead and mirror this across the center. Our mirror line will be the center line that I made. And I accidentally escaped out of it because that's what I do every time I make a mirror. We'll mirror the circle. That's great. Okay, cool. Now these are symmetrical, so that's nice. We'll figure out the actual placement of them later. Maybe we'll just put them a good, I don't know, 10 millimeters from the edge. That seems reasonable. No, let's make it tighter. Let's actually put this. Let's actually go ahead and move them out to the edge because we really want those edges to be fastened straight to it. So let's make sure it's far enough from the edge not to actually run into any trouble with the with screwing these in, because we are threading directly into the plastic. We don't want to break anything, so we do want to make sure they're not too close to the wall so it doesn't just break through here. Let's pop it in a good, I don't know. Let's make sure they're, let's see, 3 is the diameter, 3/2 will be the radius, and then let's have a good, okay, this is where this handy print comes in. This is where, in case you're just coming into the stream, I was showing off this fantastic tool. It's like a little Swiss Army knife, but instead of actual tools, it just has different wall thicknesses. 1 millimeter through 5 millimeters. And like a lot of people say when I introduce this tool to them, they're like, I have a ruler. I know how big a millimeter is. And I say, it's not for knowing how big a millimeter is. It's for feeling how big a millimeter is. And because this is printed out of the same material that I'm going to be printing this piece out of. So if I can feel how strong these walls are going to be, depending on what thickness I print them, that's really valuable to me. So I feel like I want a good 3 millimeters between the edge of this, the shaft of the bolt, and the exterior of this. That's plenty of room and will be strong enough in order to hold up. I also have to consider the head of the bolt on the other side, because we're going to have to figure out how to interface with the larger diameter here. So let's actually give it a little extra room. What is the diameter of this? We're looking at like 5.5 at most. Wow, that's hard to see. So let's make it, let's actually do 5/2 plus 3 millimeters. Yeah, see, that looks right. And why is this still blue? That's my question. It should be fully dimensioned, so it's a little strange that I can still move it around. Sometimes Fusion 360 has this difficulty. In CAD, it's always a good idea to have everything fully dimensioned so that when you're dragging stuff around, you can't drag stuff around. It's always like fully fixed in place. Sometimes I just can't figure out where it's missing that dimension. Like in this case, it doesn't seem like any of this can actually move. And it seems like I've dimensioned everything. It's 5.5 from the wall. It's centered between the two lines. And the actual size of the circle is fully dimensioned. It shouldn't be blue, but whatever. It's a prototype. We'll figure out where we're going wrong next time. I'm sure it'll be fine. Says me. Oof. Okay, so let's take a look. Yeah. So we're just going to keep these as construction for now, since we wanted to reference them in order to really get a feel for how thick the top lip should be. Now that we have that, we should be able to, take this part. Let's drill those holes. Let's see. So we'll probably be using, I don't know, M20s length. We'll just do it parametrically. We'll figure it out later. Let's see. Carbon Speed Dating asks, is this Fusion 360? Yes. So Fusion 360 is my CAD package of choice these days. I've used SolidWorks, Onshape. I've used a bit of Autodesk Inventor, I've used Rhino, which is different, but still worth mentioning. Fusion 360 keeps me coming back, despite its, frankly, weirdly many problems, just because of its components, the way it handles components. I love the way that you have, you can make multiple items in the same file that so easily reference each other in order to rebuild itself. That may not have made a lot of sense the way I explained it, but I promise it's a pretty nice system. That being said, I've been looking to move away from Fusion 360 into other CAD programs, but there are just some things that really keep me here. And frankly, like, it's going to be difficult to not use a program called FreeCAD once I get out of graduate school, because these programs come at a hefty price tag that I don't really feel comfortable with affording when there is a free option. And FreeCAD is surprisingly capable. Maybe I'll do it for a stream at some point. I'm going to be significantly less, capable with it, which will be a little embarrassing. But hey, you got to be bad at something before you get good. So let's think this through. In order to sandwich the actual, in order to sandwich the piece in here, we're going to need the other piece of bread. We've got this piece of bread. It's going to sandwich one side. We need a piece that, we need a piece that goes on top of that. So let's make a new component on the main enclosure. And we're going to call it, always name your components. If I see any of you not naming your components, I'm watching you. We're going to call it transparency top support. Cool. Okay, let's create a new sketch on this surface, and we're just going to make the transparency top support. We're going to use this piece right here. We can actually take all of these, well, not all of them, most of them, and make them construction geometry, just so it doesn't confuse the program. Now the only profile being viewed in this is this top one, so that's nice for me later. And really, all we have to do is extrude it out to a very reasonable size. Let's go back to my Swiss Army knife of thicknesses. I want to make this thick. At the very least, I want it to cover the entirety of the head of this bolt. So let's see, head of this bolt is running at 3 millimeters. So let's add 3 millimeters for it to sink in. And then how many millimeters do we want it to actually have to like pull against? Like the bolt has to pull against some surface, and we want that to be a strong surface. So let's do, I've really been liking a 2.5 millimeter structural surface. I always think it's the thinnest possible to make it, strong, and have like a few, layers that are really like solidified, but also not too thick. So let's do 3 millimeter depth plus 2.5 millimeters. That way, let's see, and let's make this whole thing negative since I am extruding it out. Oh no, it's extruding the correct direction. Never mind. Cool. We're gonna make a new body with it. Bam. Now we have the little sandwich piece, and we can start drilling our fasteners. Ooh, okay. I'm glad I didn't get blasted in the chat, because I've violated my own rule here. I see a sketch here that is just called Sketch 10, and I'm very disappointed in myself. I always name your sketches. If I see your CAD documents and it's sketch 1 through 15, shame. Yes, in the chat. Carbon speed dating. Shame. Shame. I am shamed. We have to rename this. So this is the, what do we want to call this? The collar? Collar seems like a good name. I feel like shield, walls. We already have walls. They're the walls around the actual glove, like the medical glove box. So let's call it collar for now. Let's do this collar. Wow. Suddenly collar just looks wrong. Am I spelling collar right? Yeah, no, that's right. It's just, I have doubt in myself. That's fine. And also let's do collar and top fasteners. Because we've got them both in one sketch. Usually I try to keep it to one idea per one sketch, but you have to make exceptions sometimes because the thickness of that top of the collar was really dependent on where we place these fasteners. So it makes sense that we included them both in one sketch. We'll call it for now. Call it good for now. All right. So let's go ahead and drill our fastener holes. We'll project them through onto our fancy new sandwich piece. Let's highlight them. Ooh, they are in there. Oh. Wow. Yeah, sketch arc. Oh, wow, that is highlighted. It's just very dark. And then, boy, the other one is here somewhere. Can you all see it? That is, oh, there it is. Okay, we're projecting both of these forward onto the current sketch plane. I didn't even make a sketch. Oh no, I made a sketch, but I didn't even name it. Oof. The sandwich bread. We're gonna call it sandwich bread because that's what it colloquially is. Oh yeah, alien seeking cow. So I manufactured the wall thickness tool myself, but I didn't design it. That honor goes to we'll find the Thingiverse model real quick. I know I saved it in my tools. We're looking for tools. Here we go. I found this from a very clever designer. Let's see if I can talk slow. Ah, here we go. So here's an even better look at it too. This is Roykin 7. This dude did a bang up job. I use this thing all the time. It's just it's more useful than I thought it would be, and I feel like that's a consistency in this tool. Is like people are like, well, no, I know how large a millimeter is. I'm like, yeah, but so yeah, props to this dude. They really knocked it out of the park. Easy print, well dimensioned, really useful, and good looking too. It's a good looking print. Anyway, so let's go ahead and cut these holes. So we're gonna make a new sketch on the front of the sandwich bread, and we're gonna project in those circles. Let's hit that project tool. We've got one. Let's flip it around, get the other. Cool. Now we've got them on the front. They're, I'm moving this around a lot. You can see them here and here. Okay, so let's also, we should sink the head of the bolts in so that it's flush with the exterior. I already forgot the measurement of the head. We'll go ahead and call that a good, wow, precisely 3 millimeters. How cool is that? So we'll sink the head in 3 millimeters, and we need the diameter of the head for that, which is, let's make both of these equal, so I only have to dimension one of them. Cool. Thickness of the head is a good 5.35. Let's make it a little larger just so that it doesn't like jam and I don't have to deal with tolerances. Let's make it a good 5.7. That seems reasonable. Cool. Now we've got 2 extrusions. We can go ahead and pop them both in. We'll extrude both. Actually, yeah, both. One issue that I have is I also enclosed the head of this side of the sandwich bread, which is a little, I don't know. I don't want that highlightable, so I'm going to go back into this unnamed sketch. Hold on. Fastener pattern. Whew. Shame. Okay. Y'all just yell out shame every time I forget to name a sketch. Okay. In this fastener pattern, I do want to make the face of the sandwich bread unselectable. So we're going to go ahead and let's just hide the dummy glove box for a moment. It's really getting in the way a little bit of my selections. Let's take this, let's take all the edges of this, and we'll just make them construction lines, which make it, yes, shame in the chat. Construction lines aren't actually used in anything but the generation of the model. So they're really useful. Like, it's probably one of my top used features of any CAD program is construction geometry. Speaking of which, I'm going to throw some shade on Shaper 3D, which is an iPad CAD program that doesn't have construction geometry, and I can't use it because of it. Such a bummer, because I'm really looking forward to a history-based CAD like application for the iPad. That would be so nice. I'd love to do this stuff on the run, but I just can't. But maybe someday, once enough people understand that CAD is actually super duper fun. What was this? We're looking at a 3mm flat. Let's just drop it in 3mm, and then we'll do the same thing with these. We should probably do this from the sketch, not just the surface. We'll take these 2 surfaces and we'll pop them in. Let's go ahead and extrude them. Okay, we're not extruding out. We are extruding inwards. So let's pop them in and cut this. We're going to be cutting both the enclosure part and the sandwich bread, which maybe I shouldn't call it sandwich bread. I just think it's funny. Okay, so this is, what sort of bolt is this? This is an M330. Question is, do we want to use a full M330? I don't think that's necessary. We could probably even go with an M10 or M20, maybe like an M15. That looks about right. There's enough of this, threading inside the part to really, get enough grip to make this stick. Either way, you know what? Hold on. Let's actually make sure I have some M15 bolts. Because if I don't have any and I make it, then oof. Here they are. Cool. We're looking at, oh yeah, this looks like I still have plenty. I've got plenty of M10s. Looks like I've got a few, what are these? M3, sorry, not M10s, M310s. Yeah, I've got some 15s. This should do great. I've got exactly 6 of them left. Ooh, maybe we should go with like a M12 or something. I don't want to use up my entire supply on this. These are M12s. Got some, sorry, not M12s, M312s. Oof. I've got some M14s. I think some M3, so 3mm wide shaft with a 16 millimeter long, thread. That seems about right. We'll grab 4 of those and we'll call it good. Let's see. We probably also want one in the middle. We'll deal with it later. Either way, we're going to start this extrusion from where the head ends. So we're going to start from an object, which is this, and we're going to go inwards. And we're going to cut in. Is this doing it right? No, we're starting from an object. It's this object. Yeah, there we go. Now we're talking. And we're going in how far? Did I say M16? I think I did. Okay. M14, sorry. You know what? M3 by 10 bolts are probably the most common bolt in the 3D printing community. M310s are, you get, when assembling 3D printers, they are the most prolific. So what does a negative 10 millimeter look like? That looks to me like it would have enough threading in there. Why don't we use the most popular fastener? It's always a good idea. Just make it easier to source the parts for this rather than an M14 or whatever. Yeah, that's what I'm going to do. Perfect. Okay, we'll make them M10s. We'll do it right. Cool. Now we have the sandwich piece with an M10. Oh, wait, did it not cut? Looks like it should be cutting. Oh, no, it needs to, I messed up because I didn't actually cut the interior on this one. So we can fix that real quick. We can just select both of these profiles and it'll be fine. Cool. Okay. So now we have, let's hide that. Cool. Now we have an M10 part and we can pull this to the side. We can see how this will sandwich the piece of transparency. So that should work. Let's go ahead and nice this up too a little bit. We'll put some chamfers on here just to make it look good. Just a nice little 2 millimeter chamfer. That seems good. Awesome. Maybe we should also put one in the center. I don't think we'll need one. No, let's just skip it. If I don't think we're going to need it, then I can just drill one in post-print. It's a prototype. I feel like I'm saying that a little too much. It's a prototype. It's fine. I'll get away with it. This is going to kick me at some point. Let's go ahead and revert this position. So now we have the front of the sandwich. We should be done with the top of the interface for the transparency sheet. So, hey, interface complete. As far as stuff that we're on right now, we're designing interfaces. We've got let's write out just so we can keep track. Big writing. Interfaces. We've got interfaces with the box. Check. We've got interfaces with the wall. Check. We've got interfaces with the transparency. And those interfaces are the top and the bottom. We can check off the top. Now we work on the bottom. The bottom is a little more difficult because I still want to attach that one using these magnets. I still have some of these bar magnets left over. Should supply this nice snap closed when it gets pulled closed. So hopefully we can get that looking good. Uh, Question is, should I label the transparency, or should I model the transparency just for frame of reference? Because I'm tempted to skip it. I'm tempted to not do that portion of this project, but I did promise myself that I would do that from now on. I'm not going to do it. Yeah, no. Also, I realized that my Discord little notification thing was in the upper left the whole time. If that was bothering, sorry about that. But regardless, let's go back and start editing the main enclosure again. Now that we have that sandwich portion, you know what? Let's go ahead and model the transparency. It needs to be modeled anyway. Wait. Can I model the transparency before modeling the interface between it and the bottom of the enclosure? I'm a little worried that I'm not going to be able to, because the length of the transparency, the length that I cut it to, is going to be determined by the length of these feet right here. So if I model the transparency beforehand, you know what? Let's model the transparency longer than it needs to be, and then we can cut it down in the program too when we figure out what its actual length needs to be. That way we can imagine it in the same way that we actually make it, which is pretty exciting. What else is... seems like some of these things aren't fully dimensioned, but that's okay. We'll figure that out later. My ambition for an all-night CAD session is maybe a little too ambitious. Also, I'm tired of looking at these sharp corners up here. Just for my own peace of mind, I'm going to do a nice chamfer on them. I think it just looks cool. Why not have your project look cool the whole time instead of just at the end? Nice. Very cool. And then the dummy box is going to stick out of the corner there so you can nicely grab it. Oh, great. All right. Yeah, let's go ahead and model the transparency. We'll even do it before the top support. We're going to make a new component to the enclosure, and we're going to call it transparency sheet. Start a new set, new sketch here. We'll take this and we'll turn it into construction geometry, so we don't accidentally do that. We can keep some of these though. Let's just go ahead and make it the size of the enclosure itself. Let's see. Let's project this one through so that we can reference it on this line. We'll call that the end, and then we'll also do the same on this side. Now we've got a full sheet. We'll just call that the size of our eventual transparency. Seems like a good plan. Let's see. Seems like if you aren't using, you won't need to show it. Yeah. So my last project, let me give you guys a view of what I did last. I made this cooperative drawing machine. This thing was pretty fun because usually the only parts that I printed were these supports and the brush harness, which is this piece right here. But for this project, I really wanted to display, I really wanted to work on my CAD work, and I really wanted to fully use the component system of Fusion 360 because it's a lot of fun and it's really nice to have around. So what I ended up doing is I modeled everything, even if I wasn't going to print it, from the MDF board that I used as a base to the paper to the brush itself. I modeled it all, and it did really help me make the model. Here's a time lapse that you can see. I started out with the size of the MDF board. Then I modeled the dowels in order to get a feel for how things were going to be. Then I modeled the supports, and after that I modeled the brush harness. And the brush harness. So modeling the brush and the dowels were actually very helpful to modeling the thing as a whole. So I promised myself, now whenever I do, new models, I'm going to take the time to model the pieces that I'm not going to print. Let's see, how thick is this transparency? We're looking at only 0.24 millimeters thick. Am I zeroed out? 0.24. So we can extrude this to that exact 0.24 millimeters. And let's go ahead and make it transparent too, just so it's not, Oh, we can just edit the opacity of it, actually. Let's edit it to almost nothing. Transparency sheet. The body, which we're going to call transparency sheet. Oh, man. Did I miss a shame in the chat? Because look what I did. Transparency sheet dimensions. Dimensions. Whoops. Cool. Okay, great. Now we can take this piece, the body, and we can make it very transparent. We'll make it 10%. Whoa. Did that actually work? Does not seem like it worked. Maybe it's because everything else is not transparent. Yeah, it looks opaque to me. What's going on here? Transparency sheet. Opacity, 10%. Yeah. Is it actually? Yeah, so it is a separate object. So let's just go ahead and take this, set it to full opacity again, and try and set the component to a different opacity. Hey, there we go. Now we can see the transparency sheet as just a nice little loose piece. And this is a good idea. Since I've modeled the transparency sheet, we can actually take the top support and we can, instead of placing it directly on the part, place it on top of the transparency sheet like it actually would be. So let's go ahead and... Oh, man, do I care that much? Because I did use... Yeah, I care that much. Of course I care that much. Okay, let's redefine this sketch plane to be the transparency sheet. Cool. And let's edit the sandwich board. So it is missing these sketch lines because they are no longer projected. Let's go ahead and make sure they are newly projected. We'll hide the transparency sheet for now. Use the projection tool to project this whole surface. Actually, you know what? Delete this whole thing. Cool. Now we can do a clean projection. Probably didn't need to do that, but whatever. Make some parts of it. Reference geometry, and then close off the section we actually care about. Cool. And let's make sure this references correctly. We've got a few errors, but we're going to just go through and fix them. That looks good. And that looks good. Now we just need the chamfers, which lost their original geometry, so we can just go in and replace them. Let's make it 1.5 millimeter chamfer. That looks really good. Cool. Okay, we're back up to date. What a treat. And man, you know, something that I always feel weird about when doing CAD streams is how little progress I actually seem to make. Hopefully I've been talking through my thought process enough to convey that when making an entirely new object, there really isn't anything to design against. Like there's no solidified piece that I can reference to really know what I actually want this to look like. So a lot of my time is spent really hemming and hawing over the mechanics of how I want this to perform. And on stream, that can seem a little dull. I try to resist that because I do really value that process. But it does give me a little anxiety. So let's go ahead and unhide the transparency sheet. And now we can figure out what the interface between the transparency sheet and the enclosure will be. And that's going to be our one of our most difficult parts yet. You know what? Carbon speed dating says it's the most interesting part. Thank you. I really appreciate that. Relieves a bit of my anxiety there. All right. I need food, and I need to not be looking at the screen for a bit. So I might cut this off here. If you want to see more CAD stuff, more late night CAD streams full of ideation and hemming and hawing, then yeah, do whatever it is you do to get that on your dashboard. Because honestly, I'd really enjoy seeing y'all again. I had a good time. Chill late night CAD. All right, see y'all later.